Today, we are entering into, as I said, cause-effect chain analysis method of problem identification. What do you think cause-effect chain analysis? This is an English phrase. What do you think it would mean? What, according to you, could cause-effect chain analysis mean?
So when there is a problem, like in organization or any problem that we are facing, so we just need to like analyze that what is the cause behind that problem, and how that problem, if you are not going to solve that problem, then how this problem is going to affect in future actually.
Okay. So in a sense, what you're saying is, if there is a symptom that I am seeing, I want to go to the root cause of it. I want to diagnose why this problem is appearing. So I'm going to ask a few whys. Why this? Why this? Why this? And go to the root cause. So you will notice that this method is also called as root cause analysis or 5 whys or many other names across different frameworks. Agile would call it in one way. Kaizen would call it in a different way. Program management, Six Sigma would call it with a different name. But essentially, all the different problem identification tools, problem identification methods have some semblance to cause-effect chain analysis of TRIZ in them. Okay, so cause-effect chain analysis essentially is about looking at what are the key disadvantages that are there in any engineering system. So we're calling it an engineering system, but we will look at a few examples and you will realize that we're not limiting ourselves to engineering systems. Okay. And the problem that we talked about just now is called as the language. In this language, it is called as initial disadvantage. And the root cause is called as fundamental cause. So the CECA is a TRIZ tool which is used to identify fundamental causes or key disadvantages in any system given the initial disadvantage. So how do we do it? Just a quick overview. Disadvantages are identified through various methods. Okay. For example, we identified some disadvantage yesterday that, okay, this is a problem that we have. Today, when we enter into the situation, when we pick up some solutions, okay, I want to have a electric car. So why is not everyone having an electric car today? Why are people still preferring ICEs and not electric cars today? See, if electric cars were
infrastructure is not properly set up.
Yeah. So why is this infrastructure not properly set up? Why is this level of infrastructure even needed in the first place? There are two different whys. Why is it not set up? That is one why, which could take you to, okay, this is new. अब इसके लिए तो आप कुछ नहीं कर सकते. But why is this level of infrastructure needed? If you ask this why, then you will arrive at some answers and you can ask further whys. So why is this infrastructure needed like this? Oh, because the range of EV is just 300 kilometers. Okay, why is the range only 300 kilometers? Okay, because the battery cannot store much more charge. That is one aspect. Another aspect is because the car consumes that kind of power. Now there are two streams here. You can further go down to why does the car consume so much power? So you say, okay, the engine needs this power, or there is the inefficiency here. And then you go to the other stream where you say, okay, the battery has this kind of a power density. Why is this kind of a power density there? Because that is the limitation of the material that is used. Why is this material used? Why is another material not used? So you can go to basic disadvantages, key disadvantages. Okay. When we say that, okay, so we will form a kind of a flow chart. Okay, this why, this why, this why. Answer to this why is this, answer to this why is this. And we will arrive at some key disadvantages. When these key disadvantages are taken care of, you will see that all the further disadvantages are anyways eliminated. See, if I can somehow increase the what do you say, the range of an electric car to, let us say, 700 kilometers, then a lot of infrastructure related challenges are already taken care of. Is it not? So a lot of them, I'm not saying all, but the problem on the other hand is significantly reduced. So cause effect chain analysis helps us identify what the root cause is and which key disadvantages, if I work on, will handle all the subsequent disadvantages that appear in the system.
क्लास वन तो करियो, सर तो बोल रहे हैं फ्रेंड
Okay.
बनाएगा तू, बुक्स में क्लास वन तो करियो, तो लैपटॉप से देख रहा है या मोबाइल से देख रहा है?
Is that okay? Any questions?
तो करने लगा।
So this is one view of it, where we say that there is an initial disadvantage. And then we go down, kind of ask the whys and identify why this disadvantage exists in the first place. And then we go down, dig deeper, and arrive at some fundamental disadvantages, which are key disadvantages. Okay. What we essentially do is, from the initial disadvantage, when we start to go deeper, we also start to build this kind of a and/or map, where we say that this initial disadvantage appears when this disadvantage 2 is there and disadvantage 6 is also there. So if you have to solve this big problem statement, which key disadvantage would you want to work on? If this is the disadvantage map of the engineering system or a situation that you have at hand, which key disadvantage would you want to work on, or which key disadvantages would you want to work on, so that both initial disadvantage 1 and initial disadvantage 2 are taken care of?
4, 8, 10.
So
4, 8, and 10.
4, 8, and 10, or only 4?
No,
only 4.
Only 4.
You see, there were 2 initial disadvantages. There were 2 major deficiencies in your engineering system, in your product, and there were multiple reasons leading to that. When you do a cause effect chain analysis, you can probably, now in this one, it seems there is only 1, but in your system, when you work on it, you may arrive at 2 or 3 key disadvantages that you need to solve. Okay, but in this example, for that matter, just solving key disadvantage 4, taking care of key disadvantage 4, would solve both the initial disadvantages. This clarity you get only when you make this kind of a map, and that is why we introduce CECA as a separate step, or as an important step in problem identification phase. Any questions till now? Okay. Yeah, Manav.
Sir, I did not understood why only removing 4 will remove all the disadvantages.
Okay. So if you remove 4, initial disadvantage 1 is taken care of. Is that evident to you?
Yes.
If I remove disadvantage 4, do you also realize that disadvantage 2 will also not happen?
Yes.
If disadvantage 2 is not happening, then what is the output of this AND operator there?
Okay, sir. I got it.
The output of the AND operator is 0. So initial disadvantage 5 is also taken care of.
Okay, so any solving disadvantage 2 or 6 would be the solution.
2 or 6. Yeah.
I mean, to
for
remove the
initial disadvantage 5, you
5,
want to
yes.
take care of either of 2 or 6. Yes.
Okay, thank you.
Yes. I know. So that is what you meant by the operator AND. And if you have to handle disadvantage 6, which all key disadvantages you need to work on?
8 and 10.
Both 8 and 10. Both of them, not just one of them. Both of them have to be worked on so that disadvantage 6 is taken care of.
Yes.
Now, do I necessarily need to work on disadvantage 8 and 10, or can I also work on disadvantage 7 and 10? Or 7 and 9?
7 and 10 or 7 or 9 can also be worked upon.
So what has happened now? Now I have a choice of problems to work on to handle my final or to handle my initial disadvantage. Are you able to see this?
Sir, I have a doubt. Sir, you just said that we can also work with disadvantage 7 and disadvantage 9 instead of 8 and 10, right? So like if we do that, but still the key disadvantages still exist, so they might arise again. So then why would we work on 7 and 9 and not 8 and 10?
You tell me, why would you want to work on 7 and 9 instead of 8 and 10? Why would like, could there be a reason?
So maybe solving 7 and 9 is comparatively easy and quick than solving 8 and 10.
There is a ready technology available to solve the disadvantage 7. And if I solve 7, then 6 is automatically taken care of. Or if I solve 7 and 10, for example, 6 is automatically taken care of.
But
however,
sir,
when I was looking at initial disadvantage 5, there may be no existing technology to take care of it.
Sir, but 8 and 10 still exist. So
Let them exist.
They might again cause problems, no?
isn't disadvantage 7 would depend on key disadvantage 8 since the arrow is like.
Yeah. So key disadvantage 8 led to disadvantage 7.
Yeah, so if we like are able to solve 7, we should be able to solve 8 automatically. That should also happen.
Solve 8 automatically, pata nahi. Let us look at it like this. I want to go to a height of 7 meters. I want to jump to a height of 7 meters, let us say, but I cannot jump as is. I need a trampoline to be able to do that. And the trampoline needs to be installed in some place and some stuff like that. Now, if I, okay, there could be, so what do I need to be able to jump 7 meters? I need to have a trampoline which would kind of give me a lift. Otherwise, the disadvantage is that gravity is there. Gravity is there, which pulls me down. And the trampoline would kind of handle the disadvantage linked to me not being able to jump sufficiently from the table that I have. If I remove the table, so let us say my table, this was the table. I am standing on a table. I want to jump to some height, and this was the key disadvantage, gravity. Now either I go to a zero gravity situation, or I do something to the table. If I replace the table with a trampoline, the gravity still exists, but my disadvantage of my surface not offering me support to jump is taken care of.
So basically, like we have found a work our way around that. Like,
yeah, so I have not removed gravity. I cannot probably remove gravity at all. But there is a solution. There is a solution for disadvantage 7. So I use that.
Okay, I see.
Okay. Sir, here you are actually saying that key disadvantage 8 is not only the way to remove disadvantage 7.
Yeah.
Okay.
It is one of the ways.
But that was the most important, as you said.
So everything was happening because of gravity.
Okay.
If I go to a zero gravity situation, I will be able to jump 7 meters. Am I right? Then I will not need a trampoline.
Yes.
But I cannot remove gravity from Earth. The situation, the setting that I am in, this key disadvantage, I cannot remove. So what do we do? Let me work on some other disadvantage. So CECA then gave you not only a smaller list of problems to work on, but also it gave you multiple options of which problem to solve. And now you can choose the simplest ones to solve. Are you able to see this?
Yes, sir.
So what we are saying is that, see, when we go to identify this key disadvantage, I said gravity over here. So what we are saying is that you should actually ask so many whys that you end up at a physical, chemical, biological, geometrical fact, something which is a fact. That many questions you should ask. That long a chain you should build actually. Where, okay, this is a geometrical fact. This is what we need. This is a physical fact. Gravity exists. Now अब gravity को मैं क्या करूं? कुछ नहीं कर सकता. So अब मेरे को किसी disadvantage पे काम करना है. But I have to actually go to that level of key disadvantage in my analysis. Are you able to see this? So while removing key disadvantage removes most of the disadvantages, it is not necessary that we remove only the key disadvantage. We could remove something else also, and that would work. Are you able to see this? Any questions?
I have a question. On the last slide, could we also extend this argument to assigning weights or sensitivities to each of these boxes, saying that, okay, removing disadvantage 7 is very difficult as compared to removing disadvantage 3, or removing disadvantage 7 adds a lot of values compared to disadvantage 3, and
yes, we can further enhance this. Yes. Why not? We can. Okay. But it is not necessary, Amit. We can do that. Yes, we will enrich the tool in that way. But we do that only if we really need to.
Okay.
No, because finally the intent is to solve the problem.
Yeah, I mean, there are times when the problem is not like a 1 and 0 problem, right? Like, for example, reducing poverty in India, for example. It's not a 1 and 0 problem. So
exactly. So yes, in that case, at that time we will want to rank. Okay, this problem is this disadvantage. Solving this disadvantage has the maximum benefit.
Exactly.
Or solving this would solve 2 more disadvantages. It would solve 5 of them. So you rank them. That we can do. In fact, when we do function analysis, you will see that we will already rank. But in CECA, we do not usually talk about ranking. But we will already rank problems. We will already rank systems, and which systems to remove, which systems to keep, and which systems to work on. We will already do that. You will see we will do that.
Okay.
But we can bring that concept here also. So very true.
Okay, thank you.
But yes, we want to keep the invention process को जितना simple रख सकें उतना रखना है, because the process and the activity in itself is complex. So as simple as you can keep it, let us keep it like that. But yes, at times a minimum level of complexity may be needed, and that we should add.
But sir, you mentioned that this model gives us comparatively easier problems to solve. When we say the easier problem, aren't we already ranking them?
So we are not. Abhi, when we are saying easier problems, Anshul, we are saying that, okay, this problem is already solved probably. We have a technology to solve this problem. The technology exists. That could be one way to say easy or not. But what Amit is pointing out is that there could be technology that would exist for, say, key disadvantage 4, 7, and 9, or 9 and 10 both. So which one to use? Should I solve 10 or should I solve 9 then?
Got it, sir. Got it.
Because I have a choice which one to solve. So then he's saying, should we not also rank between 9 and 10? And yes, we should.
Yeah, I think what I was also trying to say was that till now we've kind of limited to that. Okay, we're talking about 4, 8, and 10 are equally. We're saying all of them are 1, right? So if you solve only 4, that's better because we are just solving one key disadvantage. But imagine, I mean, what I was thinking in my head was that if the key advantage 4 is way too difficult to solve, as compared to, solving 8 and 10
So
together.
not just 4, Amit. We say key advantages 2, 3, and 4 are already are all so complex to solve.
Oh yeah, exactly. Or to put it the other way, if solving 2, 3, and 4 won't give us a lot of value in terms of, let's just say, reducing poverty, which is like 5, then why then what's the point? That was the thought process I had.
Yeah, I agree. So over here in this map, since the operator is AND operator, so we are AND operator is kind of saying, okay, ye hata diya, to bhi the problem would go away.
Oh yeah. Okay, got it.
That is the function
it
of
would
the
have
AND
been an OR
operator.
operator in that case. Yeah, you're right.
Then it would have been an OR operator. Yes. Okay, so now let's look at the one example also. Let us say you're having a headache, or someone is having a headache. So this is not an engineering system. We're not talking about you. So you ask why? Oh, because high blood pressure. This person has high blood pressure. That is where headache is happening. Oh, why is this person having high blood pressure? Because this person is taking excessive salts. Oh, why so much salt? Because of wrong diet. So now there was this headache. One solution was take Saridon right away. It would take care of your headache. But you know that high blood pressure still remains. Headache will come and go. But when you go do the cause effect chain analysis, you see that a permanent solution would probably come when you correct the diet. So do you realize there is a solution to headache? Take Saridon. There is an independent solution to high blood pressure, which is some medication for blood pressure. There could be an independent solution to excessive salts. Only eat boiled food, which would also mean diet aapne change kar li. Let us look at another set of examples. Let us say we wanted to have a drilling machine which would run for 40k hours. But its average lifetime is 20k. So why is it happening? Okay, it is happening because of 2 reasons. Either the transmission breaks easily, or the motor breaks easily, or blah, blah, blah. Why does the transmission break easily? Because bearings are weak, or gears are weak, and so on. So you can, so what we looked at in the previous slide was a simple case. Over here, what we are looking at is a slightly more complex case where you are actually working on your problem set, exact problem, and trying to solve how to handle it. For example, if you come down here across this chain, you will see they are talking about the load, the gears are thin, or the load is thin, because of which the gears break. So you say that, okay, let me make the gears thick. There would be a different problem, that the secondary problem that would appear is, as soon as I make the gears thick, the weight of the system increases, or as soon as I make the gears thick, the cost of the system increases. So then now the problem statement becomes how to make the gears thick without increasing the cost. And then this part of the system would be taken care of. Are you able to see this? So in reality, your systems will have lots of ORs instead of ANDs. But whenever there is an AND, you can always solve only one side of the story and not the other one. Are you with me? Any questions?
Hello, sir.
Yeah.
Sir, I was kind of thinking that making this graph would be also kind of challenge, because I was thinking that one of the problem you gave in the our first class of creativity, that related to writability and write speed of a SRAM cell. So the existing problem was like putting body bias to those pull-ups and accordingly and carry out the write speed. But the problem solution was already existing, but no one found it out. But when we will represent this whole thing in the form of a graph, there So how to represent those kind of conflicting things in form of a graph? Means I was not able to figure that out.
Yeah. So there are other tools for that, Devajit. Yeah, this is not a solution finding situation yet. We are, as of now, in CECA, we are only identifying a problem. You're jumping the gun. You are looking for solutions. No, I'm not talking of solutions yet.
Okay, so let's say write speed is less, so I will just point it out to the low discharge rate or low charging rate of a particular MOS transistor, something like that.
There could be multiple reasons. Okay, why is the current of that transistor low?
Okay, because
Then
the
you say
sizing.
because VDD is low. You may say the
Yes.
gate is driven to a low voltage, or because there is a small VDS.
Multiple reasons. I'm getting it.
You see, there could be multiple, and these are all ORs.
Yes,
Either of them could lead to this.
Yes.
Sir, I had one doubt.
Yes.
Sir, isn't finding the cause part of solution only? Like when we try to find a solution, we also try to find the cause. So why is it?
If I say that air is polluted in Delhi in October, I find the cause to be parali burning. Is it also equal to solution finding?
No, but it can help in finding the solution.
So it's a process of problem identification so that we arrive at a simplest problem so that we can solve it easily. But it is not solution finding. Are you able to see this?
Okay.
This is still identifying the simplest problem to solve. So we have one evident problem which we call as initial disadvantage. Solving this initial disadvantage could be very complex. So I do not want to waste my time and energy solving this final problem only. Let me find the simplest problem that I could solve. That is what the role of CECA is. We will use more tools to identify simple problems. This is just one of the tools as of now. Okay. So this we have already done. This exercise we've already done. So what I now want you to do is, so any further questions on CECA? Because now we want to then start to do some silent storming, identifying problems for ourselves. Any further questions on CECA, please? Yes, समझ में आ गया.